Hello and welcome to this special edition of panel discussion on role of simulation in decision-making in circular manufacturing systems, disseminated as a part of the European Commission-funded ReCiPSS project. Circular manufacturing systems, as we know, is an emerging paradigm in circular economy, where the manufacturing systems are designed intentionally to function as closed cycles of components and materials, with emphasis on manufacturing products that are long-lasting, easy to repair, remanufacture, reuse, and recycle. For a successful implementation of circular manufacturing systems, business model, product design, and supply chain, supported by the enabling information and communication infrastructure, need to be considered simultaneously as these elements affect each other in very diverse ways. Traditional tools and methods are not competent enough for decision-making in the circular manufacturing context, as these tools fail to capture the complex interactions and dynamics of such systems. Therefore, advanced modeling and simulation methods are needed to understand these elements and capture their mutual interactions, to make informed decisions for a transition from a linear to a circular system. In our project, we used simulation as a method to develop simplified digital representations of different elements of a circular manufacturing system that provides us information like resources required, time, and costs of different configurations. Today, we have 10 panelists representing different partners, both from the industry and the academia involved in this project, with whom we shall be discussing the importance of simulation in the context of circular manufacturing systems. From the industry, we have Dr. Aleš Mihelic, lead engineer in R&D of wet appliances at Goran Jedidi in Slovenia. Markus Wagner, who works as R&D project manager at CIECO GmbH in Germany. Saman Amir, CEO and co-founder of CirBES AB in Sweden. Rudi Bruyckere, ICT expert from Significant Svenska AB in Sweden. From the academic side, we have Dr. Faraz Yassif, Assistant Professor in Circular Manufacturing Systems at KTH Royal Institute of Technology in Sweden, Dr. Radoslav Skapa, Associate Professor at Masaryk University in Czech Republic, Nina Bushma, doctoral student at TU Delft in the Netherlands, Julian Grosse-Erdmann, PhD student at Fraunhofer Institute of Production Engineering and Automation in Germany, Malvina Rossi, PhD student at KTH Royal Institute of Technology, and Nilofer Salehi, who is also a PhD student at KTH Royal Institute of Technology. Ladies and gentlemen, I welcome you all to this panel discussion. So let me begin with our industrial experts, Aleš and Markus, and ask them about their circular economy initiatives and the role of simulations in their circular economy initiatives. So Markus and Aleš, I welcome you again in this segment. So Markus, my first question is to you. Could you give our viewers a brief overview of your automotive demonstrator in this project, and what was the rationale behind implementing such an initiative?
Yeah, thanks Samruda for the invitation and for the presentation. For the automotive demonstrator, I mean, for modern circular economy, companies are trying to retain or to regain the control over the products after the usage phase. And this is something what we are tackling in here, specific with a look on automotive aftermarket industry. Remanufacturing is a well-established concept in automotive aftermarket, and as this is also the acquisition of the used parts for that purpose. But the system has some shortcomings. In today's system, which is kind of like a deposit system, you could only return a used product to that manufacturer where you have actually purchased and remanufactured one before. And not even worse, or even worse, it is that if I return this product, or if I've bought this product, I can return the used part, but you can't, even though it's the same product. And if you compare that to deposit systems like we all know, maybe from beverages bottles, it's perfectly normal that you buy a bottle in one supermarket and when you have emptied it, you can return it to another one. And our aim within ReCiPSS is to develop the return processes in automotive aftermarket a bit more in this mainstream direction, like more oriented to the bottles. And the idea and concept which we are using for that is that of a transferable return option. So we want to describe and incorporate a return option on a digital platform, which is developed in the course of the project, and by that make this right to return transferable among different stakeholders. And by that, we want to enable more stakeholders to participate actively in the circular process, to achieve a better allocation of existing return possibilities to parts which are circulating in the economy, and also for those stakeholders who actually want to focus on their core business and who don't want to be involved so much into the circular economies, they can hand over that to some specialists or other partners who are interested by just transferring this right to return with or without the part traveling somewhere. So this is the idea, what we would like to achieve in ReCiPSS.
That's interesting. But simulation, as we know, is a very well-established tool in linear manufacturing context. What are the specific challenges, in your opinion, while applying simulation in a circular economy context?
Yeah, so I think maybe one characteristic of circular economy is that it is, compared to linear economy, it's more complex, just because you add the return flow to the overall equation, right? And at the same time, the data from these return flows is not 100% sure or not even available. And in combination, that makes, let's say, that drives the need for simplification and also for a limitation of the results which you could achieve in simulation, as you have to rely on good data for all of that. Yeah. So there is the need for simplification, but simplification needs to be done here with a very close look. You need to find ways to simplify without losing the overall point of the thing you would like to look at, and also to understand what are the limitations of your results at the end because of that limitations. But anyhow, I think simulation is a great tool also in circular environment to explore on specific questions and to develop some scenarios to adapt better to these unclear conditions, and also to try to reduce the complexity.
I see. That's interesting. So my next question is to you, Alish. First of all, can you briefly describe your white goods demonstrator in ReCiPSS? And same question, what was your motivation to run such an initiative?
Thank you for the question. Maybe a few words before where I'm coming from. So I'm coming from Gorenje, who is one of the actually largest EU producers of the white goods. So in the demonstrator, we set ourselves a goal that we will put a significant number of the washing machines. We are talking about 350 washing machines to 4 different markets in the European Union. So to Slovenia, Netherlands, Denmark, and Sweden. The choice for these markets was because we want to test different actually operation models in the system, since we have differently organized repair infrastructure in these countries. So, but the main motivation to actually for the project for us was actually to show and to demonstrate to the management and also the European Commission and European taxpayers that actually the service-based business circular models are also possible in the Europe. And for the companies, this is particularly difficult because we are specialized in producing and not so much in, let's say, providing the service. So here we are coming out of our comfort zone. And this is why I think it's very beneficial that we get some of the support for this. So in the project, we have the goal to organize ordering, repair, cleaning, forward, backward logistic, and of course also marketing and pricing and all what is necessary, that at the end we will have, let's say, hundreds of successful consumers. And let's say the system ready so that we could then scale actually this business model not only to these 4 markets but also to the other markets where we are actually making business globally.
So you raised a very important point here, that is, you came out of your comfort zone. So, and related to that, I wanted to ask you that did you see any explicit benefits of implementing circular economy in your organization?
Yes, of course. We have. We see it, as Marco said before. We see that this is actually growing market. In the previous EU project, we also see that actually it's not self-evident that every business could become a circular business or service-based business. So it's a lot of effort actually needed to have the right system and right process in the place to be successful. But since we are, let's say now a couple of years in the project, we are convinced that we will have success story at the end, and that we could have the model which could sell then and use, let's say, in 80, 90 different markets globally.
Okay, so you're quite optimistic about future of circular economy in your organization, and that was a very good point to hear. I thank you, both of you, for sharing your thoughts. And now let's move to our next segment, which is based on product design. As I mentioned earlier, product design, business model, and supply chain are 3 elements vital for the success of circular manufacturing systems. Our first segment today is on product design. Product design is a process that transforms design ideas into reality. We have our product design experts, Nina and Asif, with whom we shall be discussing the role of simulation in designing new products in a circular manufacturing system. So, Nina and Asif, I welcome you again to this segment.
Thank you.
So my first question is to you, Nina. Why do you think circular product design is important in circular manufacturing systems?
So circular manufacturing systems are closed-loop systems which strive to be self-sustaining as possible over longer periods of time. Through circular product design, we aim to sustain and add value to products with minimal time investments and resource investments before moving into recycling to make products fit such systems. And in order to achieve this, the lifetime of products should be stretched from a single to multiple use cycles, and or the use per time unit of these products should be increased. And circular products are typically designed to support maintenance, repair, and or remanufacturing, which can be supported by design strategies like design for modularity, design for disassembly, and design for upgradability. And the exact design choices depend on the selected business model and the envisioned product journey.
Okay, that's interesting. So, Asif, my next question is to you. Now, you have been working a lot with simulation of product designs. And so my very fundamental question to you is, why does one need to simulate product design?
Yes, thank you, Samruddha. My opinion is that simulations are useful to build arguments for decision making when a company is entering unknown territory. Now, the unknown territory in this context is implementation of circular manufacturing systems, or in short, CMS that we call. Now, as pointed out by you, Samruddha, earlier, implementation of CMS requires a system approach where business model, product design, and supply chain aspects are interconnected. Now, in such an interconnected environment, changes in one area of manufacturing systems will affect others. For example, the design of a product may look completely different if a company decides to lease the product or sell the function of a product as a service instead of selling the product as it is done in conventional linear system. Since CMS promotes selling function of a product as a service instead of product itself, the design of product in many cases needs to be changed. The product design change in this context could mean, as Nina mentioned, design to extend the life of the product or make the product robust that it requires less or no maintenance at all, or to make the product easy to repair or remanufacture, or all of them combined. So in principle, product designers are able to fulfill all these requirements that may be posed by the CMS paradigm shift. However, the question are, will that be economically and environmentally feasible for these design changes, right? And there could be also question, will this new design be better than the existing product design done for the linear system, or how will this new design impact the business model or supply chain or the system as a whole? So these are a few of the critical questions that a simulation model can answer, and this is what we've been working significantly in ReCiPSS project and also in previous projects that we have worked on earlier.
So this sounds good on paper, but how do you do this in reality? How do you incorporate this process of simulations in the product design process?
Not everything can be designed, simulated, I must tell, and not all aspects of product design can be incorporated in a simulation model. But through our research at KTH, we have managed to identify several critical parameters in product design that can be incorporated in simulation model, and which can create a good decision support tool and can facilitate CMS implementation. So in short, it depends on the case that you want to analyze, and also what sort of answer are you seeking. And based on that, you can identify the critical parameters in design that needs to be incorporated. So this is more or less in brief the approach that we take.
Okay, so simulation is one concept and product design is another concept. So is there any conflict, any tension when you merge these two concepts together? Nina?
That is an interesting question, and I believe Farazi has already touched upon this in his answer. So simulations are used on a regular basis for product design. For instance, if you think about computer-aided design, which is also a simulation. When using simulations to inform decision makers about the benefits of future circular product design, it is, however, crucial to select the appropriate object of simulation. So if no such circular product is designed yet and a linear product is selected to be the object of simulation, this may lead to suboptimal results, which makes it important to predetermine the type of data that still could be meaningful for decision making about these future circular designs.
I see. So Nina and Asif, thank you for sharing your knowledge on product design and role of simulations in decision-making in product design. Moving on to our next segment, which is based on business models. Now, as we know, business model describes how a company operates, makes money, and intends to achieve its goal. With growing emphasis on circular business models, the role of simulation and modeling in development of circular business models is gaining attraction. My next panelists are Radoslav and Malvina, with whom we shall interact the significance of modeling and simulation in circular business models. So Radoslav and Malvina, welcome to this segment. And my first question to you, Radoslav, the same question again. What's the role of modeling and simulation in circular business models?
Yeah, so maybe I will start with the term circular business model. So the business model is a broad term, and it's an idea of how a company operates its business. So if you want to innovate an existing business model or set up a new one, questions like these are essential. So who could be your customers? What are their needs? What product can you deliver with available resources? Who will be your supplier? How will you set up the production processes and marketing communication? And also, will it make sense financially? But the thing is, you need to find out such solution to those partial areas that will complement each other. Yeah. And the circular business model goes further, as its ambition is to establish a business system reinforcing the value retention of assets over time. And consequently, the circular business model are more complex and more difficult when it comes to the development. So it's worth to supplement the usual methods in the development process with simulations. So surveys, field or lab experimentation, time series analysis, ethnographic studies, etc., all used for data collection and analysis, cannot quantify and test the circular business model's behavior. So instead, it is this task for computer simulation.
All right, Malvina, what's your perspective on this?
Yeah, so as Radek mentioned, circular business models that enable economically viable ways to continuously reuse products and materials deal with complexity and dynamism, because the value creation in the context of business models considers the conservation of energy, materials, and value added as integral part of the early design stage, and there is a rigorous insight into the entire life cycle of the product. Therefore, circular business models should be evaluated holistically by adopting a life cycle approach. And the main advantage of simulation modeling is that it can deal with this complexity and dynamism, which is inherent in the context of circular business models. In contrast to analytical-based tools, simulation modeling tools are capable of capturing nonlinear behavior and deal with a large number of parameters. Therefore, modeling a simulation as a decision support tool can play an important role in providing systemic quantification and exploration to properly analyze business models from both an economic and an environmental point of view. In fact, in the context of the ReCiPSS project, we developed a multi-method simulation model that combined agent-based, discrete event, and system dynamics, which they actually represent the major simulation modeling paradigms. And the aim was to evaluate both the economic and the environmental performance of pay-per-wash offering. So these tools can support decision makers, in this case, the white goods demonstrator, to estimate new revenue streams, life cycle costs, and life cycle environmental impacts, and identify the most promising business approach from both an economic and environmental perspective, I would say.
I see. So both of you agree that circular business models are a very complex topic and they involve a lot of aspects. So my question to you is, Radek, in your opinion, which is the most promising area when it comes to simulations in circular business modeling?
Well, as a general method, computer simulation can shed light on almost any element of a business model. But to my best knowledge, and in my view, the computer simulation can generate the most benefits for understanding the customer behavior. You can model demand over time and estimate its consequences for production or logistics, capacity planning. It can estimate financial flows and many other things. So finally, you can assess the business model in economic terms, and this is really what counts. Many circular business models implement so-called product service systems, so the mixture of a tangible product with a provided service. That's essential. The product service system extends the duration of producer-customer relationship. And it is logical consequence because a prolongation of product life cycle is at the very heart of the circular economy. And the simulation advantage lies exactly in its ability to quantify the impact of customer behavior on company business in this long run. Yeah.
Okay, so after all this discussion, what is the main advantage of adopting simulations in circular business models, Malvina?
Yeah, in my opinion, simulation makes investigation possible and useful, where in the real world situation, the decisions and their consequences are well separated in space and time. And currently, the implementation of circular business models is still in its infancy stage. Therefore, there is a lack of publicly available market data. So a simulation modeling approach is highly beneficial in a context where there is no market data available, because it allows the companies to investigate different scenarios and different assumptions and evaluate their consequences on both the economic and the environmental performance in a risk-free environment. So I would say that would be the main advantage of simulation modeling.
So Radoslav and Malvina, thank you for sharing your expertise on circular business models. I appreciate that. Our next segment is based on circular supply chains. A supply chain is a complex system of organizations, people's activities, information, and resources involved in supplying a product or a service to a customer. Circular supply chains have become even more complex as they involve reverse logistics of a product. These complexities can further lead to risks and uncertainties. How are simulations effective in dealing with these risks and uncertainties? Let us ask this to our next panelists, Savan and Julian, who specialize in circular supply chains. So Savan and Julian, first of all, I welcome you both to this segment on circular supply chains. And again, the same question, very basic question. What is the significance of circular supply chains in circular economy implementation?
Yes, with circular supply chain, we mean that supply chains are designed with a systemic perspective, where the reverse and forward flows are integrated, combined with performance measurement indicators, which are embedded to achieve circularity. I would like to emphasize on the fact that it is very important to integrate the reverse and forward flows, because usually in linear and then specifically in downstream supply chain, the loop of the supply chain is closed by chance. But for circular supply chain implementation, it is one of the prerequisites that the products are brought back for redistribution and remarketing.
If I like,
and
I would like to add
something.
Yes, thank you. So what is seen as waste, which will be discarded in a linear supply chain, has now value and stays within its product life cycle. So we prefer activities that preserve value, keep products within the inner loop of their technological cycle, and improve the resource efficiency of the material flows. So we see high relevance for supply chain innovation for circular economy, since circular supply chains are complex, because these include many interdependencies and also feedback loops.
I see. So you just said that circular supply chains are complex. And so what characterizes this complexity, and how does this complexity affect the circular supply chain?
Yes, thank you for the question. So regarding the procurement logistics in circular supply chains, there is usually an existing network of different partners like professional core dealers, industrial disposal customers, private returns, etc., that has grown over the years. So these networks are, usually decentrally organized, resulting in poor coordination and exchange of information among them. Furthermore, in contrast to traditional supply chains, where demand is typically perceived as the main unknown, in circular supply chain setting, however, it is the supply side that accounts for significant additional uncertainty. So used products are much less standardized, input resource than conventional component supplies or raw materials. Quantity, as well as quality and timing of products are in general not known with certainty and may be difficult to influence. And if you look at the distribution logistics in terms of circular supply chain, the logistical setup network design has to be configured according to the chosen business model. So for product service systems, supply chain innovation will be needed in the service network of circular economy. So we have to address different questions like allocation of transport routes, determination of collection channels, batching and bundling of facilities, or determination of the location of repair, refurbishment, or remanufacturing facilities. The complexity of operations lead to redundant processes throughout the whole circular supply chain, and hence decrease the overall performance of the system. So due to the lack of transparency in the circular supply chain, cores, for example, are identified and evaluated several times, creating inefficiencies, additional transportation costs, and of course also uncertainty of availability and delivery times of the cores at the remanufacturer. So in order to achieve a higher performance of the overall system, we must address the complexity involved, counteract the uncertainties, and focus on transparency throughout the whole supply chains.
All right. So a circular supply chain involves reverse logistics, which implies higher logistics and inventory costs, and thus it would make it a very unattractive option for the companies who wish to implement circular economy implementation. So what options can be used today to support such companies by introducing circular business models and reducing this uncertainties and risks? Saman?
Yes, so if we are talking about simulations and the use of simulations for understanding the complexity in supply chains, then simulations are a very powerful tool. So they can be used to estimate the risks, additional costs, lead times, return rates, and also as highlighted in the earlier segment of business models. Also, we can evaluate if a certain business model will be economically feasible. Specifically in ReCiPSS, we have tried to achieve exactly this by creating a decision-making simulation tool that focused on centralizing and understanding the centralizing and decentralizing of supply chain operations. And through that, we could benchmark the hotspots for circular supply chain implementation, and also highlight the trade-offs between environmental impact and cost optimization, and where it is most feasible to locate facilities, as Julian mentioned, because supply chains are complex. And as we move into circular economy, the complexity is not going to be reduced unless we try to understand it through different tools.
I see. And you said you tried this out in ReCiPSS project, right? So would you like to explain this with concrete example from the project?
Yes, in ReCiPSS, what we try to do is we used real data that our demos had provided us with, and we created a simplified reality for the supply chain. So for Goerenie, as Alish mentioned in the beginning of the segment, that Goerenie wants to implement a paper wash business model. And for that, a circular supply chain is needed, which means that throughout the life cycle of the washing machines, there should be plenty of washing machines available for redistribution and remarketing, especially going into the service model. So we have tried to develop, as I mentioned, the decision-making tool that lets us understand between the trade-offs between the facility location and where it will be, where a certain operation will have lesser environmental impact. So that we have tried to do. On the other side, in terms of automotive case, what we have, as Marcus was mentioning in the beginning, that the automotive spare parts market is decentrally organized, where we have a lot of stakeholders in the network, which makes the supply chains very complex, increases the complexity. The products are not available at the right time or at the right amount or in the right quantity. But for circular economy, we want to actually, that's the basis of circular economy, that we want to close the loop. So what we have tried is that we have created this decision-based decision-making tool, so that helps to quantify the environmental impact and also the cost optimization issues. But I would like to emphasize that it's not only the complexity of the supply chain that we have to address for circular economy implementation, it's also the transparency, and because starting from closing the loop and making sure that the product acquisition is in place, so we cannot underestimate the impact of using ICT and making sure that the loop is closed, the products are recirculated again and again. Yeah, that's my take on circular supply chains.
So you say circular supply chain is not sufficient enough, is not just sufficient enough for circular economy implementation. You need something else as well. So thank you, Saman and Julian, for your interaction with us on circular supply chains. And now,
thank you.
Moving on to the next segment, which is based on information and communication technologies. So until now, we saw three important elements of circular manufacturing systems, namely product design, business model, and supply chain. The interaction between these three elements are facilitated by information and communication technology platform, often abbreviated as ICT platform. Now let us discuss how an ICT platform helps us in modeling and simulation and in decision making with our next panelists, Ruud and Nilofer.
Hello.
Hello, Ruud and Nilofer. Welcome you to this panel on information and communications technology, in which you both specialize. So my first question to you is, how does an ICT platform help in modeling and simulation?
Yes, well, as you mentioned, and as it was discussed so far, CMS consists of three main pillars, that these pillars need to be interconnected with each other and communicate with each other. So because like any changes in one of these pillars can have direct or indirect effects on the rest, so it makes the system complex and complicated. So here, ICT platform can make an important role to capture these complexities and analyze the dynamism in the system, and also because it refers to the information flow and disseminating this information flow in the system. So it needs to be modeled in the system as well. So for the CMS implementation, it is really essential to assess the interconnection of these three pillars, to analyze and quantify the design efforts for different innovative circular business models, and decide the configuration of the circular supply chain to close the loop. Here in this context, modeling and simulation as part of the ICT platform tools can act as a decision support tool to help the firms and decision makers to map the real world, the complex real world, to the modeling and simulation environment, to capture the complexity of the system and to have a close examination of all the processes and activities and behavior of the agents in the system, and provide a less complex picture so they can be able to make and build different scenarios and compare these potential scenarios in a low-cost, fast and secure environment, as it is, it might be expensive or kind of impossible to deploy all these different scenarios in the real world. As an example, I can talk about the multi-method model that was developed in the ReCiPSS project for the automotive demonstrator for their new business approach, as they aim to streamline their reverse logistics with the support of a cloud-based ICT platform. And this platform was proposed to enable the process of decoupling of the physical flow from the financial and information flow to enhance the performance of the system, increase the transparency in the system, and decrease the inefficiencies. So this multi-method model that was based on agent-based and discrete events was a help as a decision support tool to assess the economic, environmental, and technical performance of the system, so that the demonstrator would be able to compare the conventional business approach with their circular business approach. Yeah, so this is how ICT can be an enabler, and also it can, as it refers to the information flow, can be also modeled in the process of modeling and simulation.
So you're implying that on one hand, ICT enables modeling and simulation, and on the other hand, it is also part of the process that is being simulated. How is that possible? Could you explain that?
Yes, as Niloufar said, that the ICT platform is an enabler of the circular business models, but it's also a very important part of the circular business processes and the business models. And if you look at modeling and simulation, there's always been a focus on simulating physical assets and their movements, because they're tangible. That's easier, you can see them. Also, economic financial flows have been simulated, but flows where information is decoupled from the physical element, what they belong to, that's not so common in simulation, and it's also hard to do. I think that Marcus also mentioned when he was talking about the uncertainties of what happens with the information. That is a very important part and can be a weakness of modeling and simulation, especially in circular business processes where information is crucial. It is linked to objects, to a goods or to a part, a component, and it should follow this goods or part of component throughout its lifetime, throughout multiple life cycles. And you don't know what happens during this period of time. There will be many actors involved, and you assume that each actor will follow the processes and will make sure that this information still is available after this long lifetime. But that will probably not be the case. So information will be lost, will be distorted. Either the number on the component will be unreadable, or an actor doesn't follow the process and the information isn't in the system. And then the automated part comes to the refurbishing site, and they don't know how many kilometers it has been used, and they actually cannot refurbish it, or not probably as good as they otherwise could have done. So yes, the ICT system should also be modeled. We should model what happens with this information. How can we improve the processes, and how can we model the processes and improve the circular business system, so that we do have good information and actually do get the results that we hope to receive.
So again, you mentioned that there are a lot of complexities involved in your models, and so how can ICT help in modeling those complexities? Or in other words, to what extent can you model complexities using the ICT?
Yes, I think that ICT has come a long way. We have a lot of data power, and we have the possibility to create complex models. So one thing we mentioned is to model the information flow and make sure that's an important part of the circular business process is modeled. Another thing is that you can have rebound effects where people are using, for instance, a washing machine in a certain way today, and then you introduce a paper wash program, and they start using that, and not only the paper wash system itself introduces, it makes it better with multiple life cycles, but maybe people get more concerned about the number of washes they make, and maybe the machine even works longer. So that would be a positive rebound. You could also, of course, think of negative rebounds. But I think it's interesting to make these simulation models complex so that you actually take into account also these kind of effects.
So you told there are rebound effects, both positive and negative. So do you think modeling and simulation can help us in reducing the negative rebound effects?
Yes, I think so. So I think as is, if you make these different scenarios, then you can actually and you retrieve data early from when you implemented the system, and you continue simulating and modeling on what's going to happen in the coming year. Then you can early detect these kind of rebound effects and either diminish them or turn them in a positive direction. I think that's possible, yes.
Okay, so coming to my last question in this segment. So how does modeling the information flow help in decision-making process?
Yeah, so as it was discussed in this, like in the complex system, the CMS system, we have the problem of transparency, and then we have the concept of multiple life cycle products. So if we add information flow in our modeling process, as well as the physical and financial flow, so the decision makers, the firms, can have a holistic overview of the system, and they can plan how to decide on the strategic, tactical and operational level, and also establish their collaborations with the stakeholders, because they have this information flow disseminated through the value chain and the system. And at the end, they can proactively manage their product life cycle through the whole value chain. So the information flow needs to be added in the process, as well as the physical and financial flow.
Okay, Niloufar and Ruud, I thank you both for enlightening us with the role of ICT in circular economy implementation as well as in decision making. I appreciate that.
Thank you.
So far we discussed different elements of circular manufacturing systems and the role of modeling and simulation in decision making in each of these elements. Now let us move to question and answer segment. I would like the participants to ask questions, if they have any, to other participants based on today's discourse. You can type the question in the chat section of this meeting. Any questions? Okay, I got one question for Alish and Marcus. What are your plans with simulation models that are developed as a part of ReCiPSS project after the project end? Will you continue, and if yes, in what forms? So Alish and Marcus.
You have difficulty to start both, so
Yes.
I will start the first one. So
Okay, so Alish followed by Marcus. Yeah.
Okay. So regarding the simulation model, I think that actually the era of simulation is just coming. The reason for this is that we will have in the future connected appliances where we could gather tons of different data. And if we could have very good business models and simulation models, we could use this data to speed up actually development process, but also on the other side, to help the companies to run better and to, in principle, be more environmental friendly. And I think that this is partly answers your questions.
Okay,
So
thank you, Alish.
So then
And Marcus, what's your take? Yeah.
Yes, thanks. Yeah, for us, I mean, our business, or let's say logistics, is a main aspect of our business in CECO, and we are constantly striving to optimize that, of course. Even though in the past the main focus on optimizing that was on let's say minimizing economical impact, and maximizing speed or minimizing stocks or whatever, and we were having kind of a blind spot on the ecological perspective, I think, in that, and this is clearly something which came into the picture also from the simulation we did in the ReCiPSS project, and I think this will be an interesting point, and we will definitely work further on with that and look more deeper also perspective, because that is widening the picture and giving a very interesting dimension to it, which we did not look so much in detail on in the past.
So in short, you're keen on continuing with this project?
Oh yes, sure.
I mean, with the findings of this project, yeah.
Yes.
Okay, so thank you, Marcus. Any more questions? Oh yes, we have one more question coming up, and this is to Asif. Who requests and performs the simulation in an organization, and why? So I think the question is who requests and performs the simulation in an organization.
So I think it in my view and opinion or experience that I have, it depends mainly on the structure of the organization. Usually it is the person who manages innovation in a company requests simulation. As you may have understood already, implementation of CMS requires radical changes in many aspects of business. When an innovation manager proposes this kind of changes, he or she will have to answer a lot of questions and convince internal people or the board member of the company. To support the argument of the innovation manager, he or she may request an analysis of the whole system. And typically it is R&D department, or in some cases it could be the external experts can also be given this task, who then identifies, the critical parameters that needs to be taken into consideration, and then collects data and create scenarios for simulation. So it's basically the innovation manager who initiate this kind of thing, and the experts could be both internal and external.
Okay, so thank you.
I could add a bit here. So because actually what we're discussing here is the circular economy and the service-based business system. And the problem which we have in the companies is that we have the simulation for the, let's say, for structural strength, or let's say for the failure to plan the spare parts or whatever. But for the circular businesses, and especially for the, let's say, service-based businesses, it's no one to actually to request this kind of the analysis, because we don't have organizational structure in companies to tackle with this. So I think that this is why it's very important that we got the chance to have this project, so that we could come to this kind of the analysis also, and that will be easier for us to set up the structures that could actually do this also in the future.
So we still have a long way to go when it comes to circular economy implementation.
But on the other side, also I see actually a bit from the company points of view a bit diverging paths, because on one side we actually see that with the Green Deal and the pressure of the Commission, and especially France, towards a huge extension of the, let's say, durability of appliances on one side, but also the spare part availability. And we have to be aware that for the consumer, the spare parts will never be so cheap as they are actually for the original manufacturer. And for us, as an original manufacturer, we see much more potential for earning money actually in the, let's say, service-based businesses. And with this, we are sure that we could also, and we prove it with Malvina's analysis, that we actually could make also the system much more suitable also for the consumer at the end, so that we have win-win on both sides. The only actually what the user has to sacrifice is that he had to become married with us for a longer time, so he cannot divorce after 2 years, but it's better that he stays for a longer time. With actually the approach from the Commission with this spare parts availability, this means that actually the spare parts at the end will be relatively expensive, and this could in longer term actually the people will decide, in spite of all the policies, that it's too expensive to repair, and they will actually choose to buy a new one. And this is why I said that I see that some issues, how the companies will turn and in which direction actually we will go as the Europe in the future.
Okay, so that was a very detailed answer, I hope. Any more questions? Okay, if there are no more questions, then it's time to conclude. So to sum up, modeling and simulation can be a very effective tool in understanding the complex interactions between the different elements of circular manufacturing systems. It can also aid in decision-making by simulating different scenarios and estimating their consequences in terms of performance, cost, delivery times, environmental impacts, and so on. Unfortunately, as many speakers pointed out, not everything can be simulated. However, incorporating few important parameters of a circular manufacturing system can definitely enhance the decision-making process. I thank all the participants for joining this panel discussion and sharing their knowledge and expertise with our viewers. I hope it was a very informative session for our viewers. So I hope to see you soon again. And until then, goodbye and take care. Thank you all.
Thank you very much. And I would like to say that thanks to CirBES to organize this panel discussion. And I think this was a very good discussion. And if opportunity allows, we should continue this kind of discussion.
Okay, thank you.